Okay, let's look at a MadAsMaths question on binomial expansion. This one I think looks trickier than it is, though it is still quite tricky. And I would also say it's a bit funny that they've used cos theta here. If you saw this question and instead of cos theta there was just an x, then the question would be effectively the same. So this question isn't actually about trigonometry. It's not about using trigonometric identities. It is really just about algebraic manipulation and your knowledge of infinite series. Okay, so keep that in mind. You don't need to really be doing anything to do with trigonometry in this. Okay, just have a go. I know it is a difficult question, but just try the first part because that should be totally within your capability. What is the binomial expansion of this? Okay, and remember this is just 1 minus x to the power of minus 2 effectively, except instead of an x you've got cos theta. Okay, so you'll get an expansion, it'll all have cos thetas in it. Once you've done that, then think about how can I make this series look like the expansion, and the second part is extremely similar. If you're able to sort of make them line up, then you'll start to see how you can use this expression to give you a value for these infinite sequences. Okay, so give that a go, see if you can make a start on it, see how far you get, and when you're ready you can check the working. But try it yourself first, pause the video now. Okay, so first step, before we even look at this series, let's take the advice of the question, which is to find the expansion of the following: 1 minus cos theta all squared. Okay, not too difficult. So this is, as I say, I'm going to just actually use x instead of cos theta because it's actually a bit, to be frank, pointless to use cos theta in this question. And instead of 1 over, I'm going to change it to the minus 2. Okay, so then what is this as a binomial sequence? That's going to be equal to, let me just do one extra little bit of simplification here. So I personally like to write it like this, okay, because then it's fully in the form of 1 plus something to the power of some integer, in this case a negative integer. So that's going to be 1 plus n times x, or specifically minus x in this case, plus n times n minus 1 times the minus x squared all over 2 factorial. Let's just do a couple more. We've got minus x cubed all over 3 factorial. Actually, I'm not going to do a couple more, that'll do. And now this is going to be simplified massively. Okay, in the first case I've got 1. In the second case I've got 2x. And then for the third case, the third term, think about what's going on here. You've got 2 factorial and you've got 2, so they cancel out. Then you've got minus x squared, and then you've got here minus 3. Now, when I said those 2's cancel out, obviously there'll still actually be a negative value here, minus 1. So really, you're just going to end up with a 3 times x squared. And then look here, you've got 3 factorial, which is just 3 times 2. And then this 3 and 2 cancel. So you're just left with this 4. And then the negative in this 4, because this is an odd power on the minus x, will cancel with one of the negatives here. So you're actually just going to end up with 4x cubed. And you can use the same sort of logic to convince yourself, hopefully, that in fact it just looks like this. Okay, and the pattern becomes very clear. And if we want to then write this as an actual sequence, let's use r equals 1 to infinity. And the coefficient of each of these is r, and then it's x to the r, let's let's do this the correct way around, minus 1. Okay, so the power of each x is 1 less than the coefficient. And the first coefficient is 1, which lines up nicely here, r equals 1 in the first instance. So therefore, what we've actually got, if we want to just answer the original, well, not question, but original hint, 1 over 1 minus cos squared, that's the same thing as the sum from r equals 1 to infinity of, hang on, what was I saying here? Yeah, r times cos theta, and the cos theta is to the power of r minus 1. Okay, so that's our sort of first hint. Now I'm actually gonna, like I said, I'm gonna disregard this whole cos theta stuff because I feel like it's more sensible to just think of it as the letter x, and I'm just going to now remove all this working and leave what's relevant. Okay, so we've actually got the following. We've got the fact that 1 minus x to the power of minus 2 can be written as the following series. Okay, and now this is we can get into looking at how does this compare to what we have here. I mean, they're pretty similar, right? This is an r, this is r minus 1. It's got the same thing going on here. So how can we force this to look like that? Well, let's have a play with it. So this is going to be equal to the sum from r equals 1 to infinity. And the only problem we've really got is that this is a fraction and this is a product. But we're working with powers here, so what we can do is we can change this r times 2 over r to the minus 1 into r times a half to the r minus 1, right? So that is exactly the same as this, right? I've just taken the two outwards as a half, and then we've got this. And now it's quite nice, right? This looks exactly like this. Okay, so therefore this is equal to, and now we just use this rule that we derived. That's equal to 1 minus a half, that's our value of x, to the minus 2, which is equal to a half to the minus 2, which is 2 squared, which is 4. Just 4. That's really nice, right? So I mean, it's quite incredible, really. We've basically found the sum of this, you know, odd-looking sequence. I mean, what actually is that sequence? It's 1 over 2 to the 0 is what? So it's 1 plus 2 all over 2. Oh God. Right, let me take a moment. I'll write out the first few terms. Okay, there we go. Saves you some time. So this is the actual sequence that we were working with. If you look at what this is, when you write out the values, you get 1 plus 1 plus 3/4 plus 4/8 plus 5/16 and so on. And a bit of a weird pattern, and yet here we have just proved if I take all that to infinity, add them all up, I just get 4. You know, this is why I think maths is so fascinating, really, isn't it? I mean, such a weird looking sequence, and you just end up getting 4. And the way we ended up proving that was through what initially looks like quite an unrelated expression. And then hopefully you can also see here now why I didn't bother with the cos theta stuff. It wasn't actually necessary. If I'd called this cos theta, I would have just said over here cos theta equals a half. It's kind of pointless. So it's a bit of an odd question in that sense. Okay, let's look at the second part. It's extremely similar to part A, really, so we'll be able to knock it out quite quickly. So in this case, we've got the following: the sum from r equals 1 to infinity. And let's do our rewrite again. This is r times minus a half to the r minus 1. And let's go back to our formula that we came up with in part A. Okay, this one here. So this tells us, okay, in this case, x is correspondingly minus a half. So it's 1 minus a half. Minus a half, so that's plus a half, isn't it? Okay. 1 minus a half gives me 1 plus a half, all to the minus 2. Hang on, does that make sense? All to the minus 2? Yep, sorry, of course, yep, because that's the minus 2 here. And that's then equal to 3 over 2 to the minus 2, or in other words, 2/3 squared. And we get 4 over 9. Okay, so again, I mean, it's odd, isn't it? You've got this, in this case, you've got a sequence where if you look at the terms of this thing, you're going to have a positive number, negative number, positive number, negative number. They're all various fractions, but if you add them up all to infinity, what's your answer? It's 4/9.